Are you understanding what I'm saying?
Yeah. Wait a minute. Hold on. You are impatience. 2.11, 2.
Is this a scratch on your watch?
Where?
Yeah.
No, it has a screen protector on it. It's bubble.
That was
2.113. Where the fuck is that?
And just look at this problem which I'm showing you. Don't look at this. I'm just telling you we don't look at the solution of that problem and we
Okay, which problem are you doing, man?
just let's read this problem.
Okay, why are you doing that?
Listen, it's the same example, then we do the actual assignment question. First we understand what's going around in this problem. Because this and these two problems are exactly the
Okay,
same.
then let me take a picture then.
Done? Uh, just open the sample folder.
First you have to learn to calm the fuck down.
You're annoying me that.
You're annoying me so much, but I'm being calm.
Yeah, because you're taking so much time to open a simple question. Look, now we have to understand this Parcel theorem. Let's see our lecture problems. Lecture notes. Let's rubber. Man, this is so hard. This is like, I'm not gonna be making you understand anything soon.
Okay, 2.11 you want me to understand, you want us to understand, right?
Yeah, look.
Calculate P and the
You know, this P is just taking the square of that problem. Yeah.
You have the solution as well?
Yeah. For we understand the solution.
What is B? Why it's written B over there?
What?
There's no B part here.
Where? No, this is 2.11.
Okay, take it all the way down. Take it all the way down.
No, because we see the solution of the next solution, which is the actual question.
Okay. Take 2.11, bro.
No, stay here because if I take all with the way down, it's gonna show the next problem, the assignment solution.
Okay. I only see 2.11. Let me try to understand that.
No.
Okay. Yeah,
no. Wait. I have another solution.
Okay. Why you hide that?
Wait.
Why you hide that? You're fucking crazy, bro.
You're insane.
Even if you see 2.12, you're not going to understand anything, so don't worry.
No, what the hell, man? We are trying to take a pattern, then we solve that by using that pattern to solve the next question. That's what our aim is like. What the hell is wrong with you? Like,
why are you freaking out?
This is it. Oh yeah. Look, let me just put it up like this.
Why are you just freaking out?
Okay, now this is the solution. Now he applied power theorem over here, and if you see his lecture notes, Sharawa's lecture notes, we find this equation somewhere like. Where did we find this equation? Relevant, are you even listening? Like, we find this equation over here. Look at this. When you realize that everything is complex. Everything is complex.
Okay. Now what?
Now we basically take the square of this problem. We basically got this equation from here. Okay, where is the equation? We got this equation from. Let me grow those extra tablets. Okay, we got this equation from here.
Mm-hmm.
Look at this equation. Then we took the square of it. Then we take the square of the problem. Okay, then we took the square.
Calculate P for sandwood wave.
We use this P.
You're just picking, like, try to understand, bro. Like,
Man.
what the fuck is that? To
Eh.
take the square of something. Maybe, Adam Pantagos has the
Man, we have to do the pattern picking.
pattern, where, like, blindly the square of this and then square everything. What the fuck is that?
That's how we study.
Mm.
If you go on understanding this thing, you're not gonna.
Like, you know what is a good thing? If you understand one question, then you don't have to memorize it. You don't have to pick up the pattern. One thing you have to understand.
Man, one thing I'll tell you, the next question is same exactly as this one.
Yeah, that's what I'm saying.
But
if you
it's
understand
using,
that,
but it's using some other theorem.
Yeah,
Like listen. Let me
but
show
you're
you.
not taking time to understand one thing, bro. What the fuck?
It's gonna say this triangular symmetry in the next question. So we have to square this thing.
Okay, let me.
And why we are taking square? Because we have to take square and then we have to basically use these limits.
Okay, let me see. What's your explanation on this? Okay, take the question. Okay, P over 1 over T naught integral naught T naught T. Where this one come from? Pascal's power theorem to show infinite sum 1 over 1 square, 1 over 2 square, 1 over 3 square is equal to 5 square over 6. So where is that come from?
Okay, it
Where's
comes.
that integral? come from?
Okay. Give me a second. Let me open it. You're asking so much questions against my will. Give me a second. Let me open my notes. Do you have your notes with you?
Yeah.
You're asking 10 questions but you don't have notes. Okay, yeah. The Power-Cell theorem comes from here. Look. It comes from here. Look at this. This is the Power-Cell theorem. This is Power-Cell theorem. It comes from here.
Fourier transform theorem. So it's in notes basically. Yeah.
People are gonna pick up patterns, so you have to pick up patterns.
At least try to understand something. Don't
Man.
follow people. Fuck people.
Man, listen, in the paper midterm you have to pick up pattern. Don't understand, cause you're gonna get screwed over here.
Okay, it's about the square thing.
Man, we just take the square of that thing and done. I'm getting confused. How do we get this thing? That's the only thing. How do we get this?
Okay, don't fly over. Let's understand first where the P over that thing come from.
I
Let me
am a bit
understand that.
confused.
Don't fly. Bro.
You have to fly here and there.
Okay, this is the one, right? Is it above this thing?
Wait. No. Wait.
Is it after that?
No. Let me do it. We just picked the pattern.
What the fuck? Okay, trigonometric FS. Okay, let me see. Fourier transform theorems and pairs. That's the title, right?
Yeah, I think so. We have to do this thing, man. P is equal to this. E is equal to this. P is equal to this.
Don't fly, bro. Like
We have to,
take an hour to understand thing, then fly.
man, we have to take a pattern.
Yeah, you just flying. This is this square, and then you fuck everything up.
Man, in control system, I'm trying to understand everything.
Understand one thing, then you can fuck everything up. So you pick up the pattern, you know. Understand one thing, so second thing you can pick up the pattern. Fourier. Where the fuck is this title? When is the day? I should start writing the date, man.
Where does this P come from?
Fourier transform theorems and.
Where does this P come from?
Okay, here we go. So here is the theorem. Like where is that? Is it above this? Where is the showing? This is the one. V, T, C, and J. This is the one. Tau over T naught.
No, this is the.
Cn over 1 over T naught.
The limit has already been listen to me. If you see the table, the limit has already been given to us. We have to just apply this. We have to square this and take the Fourier series 1 over t, and we have to put the value of vt, which is going to be this, and insert the limit and then solve it. That's it.
Okay, let me see the answer first.
And then
let me compare now. Okay, 1 over t naught, the limit is 0 to t naught. Is it given in the question?
Yeah, it's gonna give. We have to find the limit using the table. This is the table. This is the limit of the table.
0 to t naught. How do you know the limit is that one? How do you know?
Man, it's a thing. Look at this, man. It's a limit. That's
yeah, that's from the answer you're saying. But from the question, how do you know?
Then I'm 100% sure, because we in the next
like
question.
We always have to do that.
Yeah.
Then why is it t naught start?
Man, it's another question. It will have some other rule.
Okay, go to the answer. Let's see the other things. T over t naught. Why it's vt here?
Man, we just insert a value, like that's another function. And then
okay, what happened to the e power thing? You're just like whatever, man. Like, come on and understand that thing first.
we have to see the pattern, man.
Okay, okay, tell me the first thing. How does it come from? Just understand.
Man, this thing come from the table.
Mm.
This thing come from the table. This thing come from the table.
So you mean for every question is that's going to be the thing?
If this type of question comes in the exam.
Like what type of question? Like
this.
Okay, 2.1. Okay, let's say
2.112
and 2.111 look the same. Okay?
Yeah.
Looks the same. So for 2.12 also, is it the same answer?
No.
In the first
look
one?
at the wave. What is it? Triangular wave.
Okay, so sawtooth wave has that one.
Yeah, triangular wave have this one. Look at your answer.
Now I understand. You have to say the wave difference.
Man, that's the pattern.
Okay, you're saying this is the answer. If you say the wave name, I should have understood by now.
And this is and then we use this limits to solve it.
Mm-hmm.
Now look at this. This is modulus. So what do we do with modulus?
Modulus mean
t/2, and I think so it's going to be minus t over 2, or it's going to be 0, something like that with modulus. I don't remember it. But the thing is this, that we don't care about this. The main thing is this: how do we get this Poisson theorem? Over here, according to the professor, Poisson theorem is going to be like let me say, so where is Poisson theorem? Give me a second. Yeah.
Okay, where is the table? Where did you get the table?
It's at the end of the book.
Okay, can you show me the table?
If you
I'll take a picture, man. I need that. Okay. Okay, that's great.
Just see the pattern, man, what's going on. Pattern. Really?
Yeah, like pick up one by one. Don't fly around and fuck it all up. You know.
I fly here and there. Are you literally screen recording yourself?
Yeah, I'm screen recording all the assignment, every notes. From today, I'm gonna record because at the beginning I don't know how to screen record and voice at the same time. Now I figured it out. So now I can record lectures. Live stream is one of the thing, and writing notes is another thing. Everything is gonna be recorded.
Okay.
Yeah.
And he said, look at this. This is the problem.
What problem?
Look at this is the problem. This is Purcell's power theorem.
Purcell's power theorem.
This is the Purcell power theorem.
Purcell's a fucking pervert. Is it after that? How far from that previous one? Too far or before that?
It's after that. It's the second last lecture.
Fourier superposition with
It's the second last lecture.
Fourier transform pairs.
It's the second last lecture.
Purcell's power theorem, yeah.
Now the issue is this, that I'm getting confused. Where did he get this coefficient Cn? Where did he get this thing?
What?
Where did he get this thing? 2 over pi over n. Where did he get the Cn? This is Cn which is given up over here, but how did he change this to this? That's weird.
Half n is equal to 0, 1 over 2 phi n is equal to... First we have to see the question to understand that thing. Let me see that. Don't change it.
Wow. Question is not going to
Question
give you
2,
anything.
find 11. 1 over 2 square and also 5 square divided by 6. You is asking how did we get 2 over 5? The n. This is Purcell's power theorem. Purcell's power theorem says Cn square. N is negative infinity to infinity. 0 plus 1 is 1. Negative infinity to infinity. Cn square. Cn square. Come on, man.
What the hell? What?
Let me see.
You just put some effort and you're like, okay, let me just take my phone. Where did this thing come from?
Purcell's power theorem. Okay, negative infinity to infinity. Purcell's power theorem. Cn square. What is Cn? Do we have experience on this yet? Purcell's power theorem. Maybe we had to watch video on that. Purcell's power theorem.
Sharava's video.
No, somebody else video. If Sarava explained, it should be here. It means Sarava didn't explain the shit.
No, he did explain it. He explained it not. You're already in teachers. Professor.
Purcell's.
What? We don't need this derivation. We need to understand where did we got that value.
Power theorems, circle theorem, geometry, Purcell's power theorem.
Wow, you're clue as me. Literally.
Hmm?
Are you literally clueless like me? Where
Yeah,
did
at least you studied some shit, bro. I'm studying right now. The servers, parcels.
Russell theorem, you have to just, but where did we get the CN coefficient? Where did we get the CN
Don't
coefficient?
freak out. Don't freak out.
Hello, this-
Relax. Relax is everything. Fourier transform. Professor Naso Academy explains that shit. Yeah, so many people explain that shit, bro.
No, we don't need this derivation. We need to know how do we get this solution. That's what we are concerned. Even Sharavas told us this is the theorem. We have to just plug in. Where did he got the CN value?
Okay, just go to YouTube.
I don't need to see YouTube. Why do you go to YouTube? I don't go to YouTube.
That's easier because we can watch some shit. This is okay then.
You watch some shit. I don't want to watch some.
You don't want to learn them.
I want to just pick
If you
pattern.
don't, yeah, if you don't know something, you better learn something from somewhere. Don't
What?
be so too egoistic.
And I'm just gonna pick up patterns. That's
Don't
how
be, Don't be too egoistic, bro.
You see the pattern.
Egoistic doesn't help.
You understand. I see pattern.
Author and creator of Transformation Week. The 11th property is Parseval's power theorem. This theorem originates from a theorem about series given in 1799 by Marc-Antoine Parseval, and later the theorem was used in Fourier series expansion. So first I will give you the theorem
Can
and
you use
then we'll prove
headphones?
it. So let's assume there is a signal xt.
Why you don't even
and
want to
the
listen?
signal is
Yeah.
having
What the
a
fuck,
complex
man?
exponential.
Then how the fuck you're gonna learn?
I-
He explained the CM. This is what happens. You be too egoistic. Learn from somebody. If you don't know, learn from somebody.
Man, we passed like 3 years of engineering without understanding.
Summation.
Yeah.
At least try to understand some shit right now.
We passed engineering like 3 years. We're gonna pass inshallah ta'ala
So this is
rest of the
Marc
1.5 years
Antoine
also.
Parseval's
Because
power
without,
theorem,
like,
and
if you don't know something, you have to understand from somebody who knows it, you know. That's the shortest
this
cut.
theorem, we can easily calculate the average power of the given signal if we know its complex exponential Fourier coefficient. So let's move to the proof of this theorem. We know the complex exponential Fourier series expansion of a given signal xt. It is equal to summation n equal to minus infinity to infinity Cn, which is the coefficient of signal xt, multiplied to e power jn omega naught t. Now I will take the conjugate on both the sides. On the left hand side I have conjugate of signal xt, and on the right hand side I have summation n equal to minus infinity to infinity Cn conjugate multiplied to e power minus jn omega naught t. We have negative sign here because of conjugate. Initially we had positive sign here. Now what will happen if I multiply signal xt and signal xt conjugate? I will give you one simple example to understand what will happen when we multiply xt and xt conjugate. In this example, I will assume a complex number z and it is equal to a plus ib. Now if we take the conjugate of z, we will have a minus ib, and we know mod of z is equal to under root a square plus b square, or we can say mod of z square is equal to a square plus b square. Now we will multiply z and z conjugate. This will give us a square minus I square b square. I square is equal to minus 1, so we have a square plus b square, and this is equal to z multiplied to z conjugate. So a square plus b square is equal in the two equations. This means left hand side of the two equations are also same. So z multiplied to conjugate of z is equal to magnitude of z whole square. Now in the same way we will write xt multiplied to xt conjugate. We will have magnitude of xt whole square, magnitude or mod of xt whole square, and we know the formula of average power. The average power of signal xt is equal to 1 over t naught integration 0 to t naught mod xt whole square dt. Mod xt whole square, we can write xt multiplied to xt conjugate. So we have 1 over t naught integration 0 to t naught xt multiplied to xt conjugate dt. Xt conjugate is equal to this. So we have 1 over t naught integration 0 to t naught signal xt multiplied to summation n equal to minus infinity to infinity cn conjugate multiplied to e power minus jn omega naught t. Cn conjugate multiplied to e power minus jn omega naught t dt. Now we will rearrange this and we have summation n equal to minus infinity to infinity cn conjugate 1 over t naught integration 0 to t naught signal xt multiplied to e power minus jn omega naught t dt. Now if you look at the rearranged formula, you will find 1 over t naught integration 0 to t naught xt multiplied to e power minus jn omega naught t dt is the formula of complex exponential Fourier coefficient Cn. So we can write the average power of signal xt is equal to summation n equal to minus infinity to infinity conjugate of Cn multiplied to Cn. And from here we can write Cn conjugate multiplied to Cn equal to mod Cn square. So average power of signal xt is equal to summation n equal to minus infinity to infinity mod Cn whole square. So we have proved the Parseval's power theorem, and in the next presentation we will solve one example of Parseval's power theorem, and in this way we have completed all the important properties of Fourier
That's
series
better
expansion.
example. We need to see an example.
Important property Parseval's power theorem, and in the next presentation we will solve one example of Parseval. In the next presentation,
Why are you writing?
Hmm?
Why are you writing?
Because it's all recorded, bro. You know, there's a connection. When you write something, you remember more. Okay, let's do the next example. This one we can discuss. He's going to solve an example.
Power theorem, and in this way we have completed.
Yeah, don't
all
put your
the
ego
important
outside and watch it.
properties of Fourier series expansion.
Okay, click the next video.
Hey man, just make a list of your closest 100 family members and friends and call them up, tell them about your business. Your business will grow and your team will be groovy, right? Alright, hey, it's Tyson's honor, of course.
Why don't you use an ad blocker?
Hmm?
Why don't you use ad blocker?
This is not Google Chrome.
Today's tutorial is a basic tutorial on how to calculate Fourier series, and also we'll look at some of their properties.
Man, it's just solving it. This is not the question.
Exercises involving the
Oh,
calculation
this is some
of
other
Fourier
guy.
series. And we'll also look at an identity called Parseval's identity.
The 11th property is
Parseval's
Parseval's power theorem. This theorem originates from a theorem
Yeah.
given in 1799 by Marc-Antoine Parseval, and later the theorem was used
Signals
in
and
Fourier
system.
series
It's in the
expansion.
signals
So
system.
first I will give you
That's
the theorem,
craziness.
and then we will prove it. So let's assume there is a signal xt, and this signal is having the complex exponential Fourier coefficient equal to Cn.
Have you wasted enough of your time?
The time
Hmm.
period.
When you try to learn something, it's never waste of time.
Now, if you calculate the average
pick the
power
pattern
of
up,
sigma
man.
xt, let's represent
You
the
have to
average
square it and square root it and fuck it up.
power will be equal
Even the tablet is like, do it, man, do it, man. Listen to him, forgive him, and he's intelligent. He's intelligent.
So this is the Mark-Antoine Parseval's power theorem, and this theorem is very important.
Mm.
Using this theorem, we can easily calculate the average